Good afternoon all. I am Mayura Apte, a PhD scholar working with Dr. Rashmi Tupe at Symbiosis International Deemed University, Pune. So today I'm going to present my research work which is entitled as Glycation and Dyslipidemia Cumulatively Initiates Diabetic Tubulopathy in Diabetic Kidney Disease. So diabetic kidney disease is prevalence is increasing, and it is diagnosed on the basis of two criteria, which are albuminuria and EGFR, along with renal biopsy. However, by this time, the patient already reaches the advanced stages of the DKD, rapidly proceeding towards the renal failure. And these two criteria, they mainly focus on the glomerular damage of the kidney, neglecting other parts of the nephron. Interestingly, it was found that around 20 to 60% of diabetic population did not develop albuminuria. Instead, they showed elevated levels of tubular injury markers preceding tubular damage preceding the glomerular sclerosis. And hence, it was proposed that at the onset of the hyperglycemia, these proximal tubular cells of the nephron, they undergo hypertrophy, proliferation, and increased reabsorption of many molecules that leads to the oxidative stress, inflammation, and apoptosis, responsible for diabetic tubulopathy and leading to the diabetic kidney disease. And hence, the overall research paradigm has shifted from classical diabetic glomerulopathy to emerging diabetic tubulopathy. There are many pathogenic factors which are responsible for the DKD pathogenesis, and one of them is hyperglycemia mediated non-enzymatic glycation reaction, and another is dyslipidemia leading to the lipotoxicity. As discussed in the morning, the focus was on early detection of the DKD, and hence considering this emerging diabetic tubulopathy and these pathogenic markers, there is a need for early detection marker of DKD, and it is also the need of an hour. And hence, we have designed the objectives as to study the impact of glycation and lipotoxicity association on RAGE SREBP axis in renal proximal tubular cells, and to evaluate the influence of glycation and lipotoxicity on inflammation, mitochondrial dysfunction in diabetic tubulopathy in renal proximal tubular cells. So, as I said earlier, if the glycation is a non-enzymatic reaction which is occurring between the free amino groups of the protein and the free carbonyl groups of the sugar, that is leading to the formation of AGEs. So, these AGEs, they bind to the receptor RAGE, further activating NF-kappa B, that is downstream signaling, and upregulating RAGE in a positive feedback loop. Moreover, in dyslipidemia, these fatty acids, they enter into the cell via its receptor and activates SREBP, which is responsible mainly for the synthesis of saturated fatty acids, and that activates in a loop translocating from ER to Golgi to the nucleus, and that this whole scenario leads to the inflammation and lipid accumulation. Moreover, the ectopic lipid accumulation is also responsible for mitochondrial dysfunction. And hence, this overall scenario again leads to the diabetic tubulopathy. However, the molecular crosstalk between glycation and lipotoxicity that is responsible for diabetic tubulopathy is not yet known, and that is the need of an hour. So for that, we have glycated HSA, that is human serum albumin, the abundant plasma protein, with methyl glycol, that is the glycating agent, to produce glycated HSA, that is GHSA. Simultaneously, palmitic acid, one of the saturated fatty acids, was prepared, and renal proximal tubular epithelial cells were maintained in their specific medium. They were treated with this GHSA and palmitic acid for 24 hours in the presence of FPSZM1, that is RAGE inhibitor, and fatostatin, that is the SREBP inhibitor. And further, we have analyzed various glycation markers, oxidative stress markers, gene expression profile, and ATP levels. So we have observed that initially we wanted to see how the palmitic acid is causing the lipotoxicity in these RPTCs, or inner proximal tubular cells, and we observed that with increased concentration of this palmitic acid, they are reducing the cell viability, and 50% viability was observed at 300 micromolar. Further, we observed the association of glycation and the palmitic acid increasing the glycation markers, these are fluorescent AGEs, and it has also affected the cellular morphology and induced oxidative stress. after that, we have analyzed various signaling molecules, RAGE, NF-kappa B signaling, where we have observed that in the presence of GHSA and palmitic acid, there is upregulation of the RAGE along with the NF-kappa B, indicating the inflammation as compared to the glycation treatment alone. And then SRBP signaling was also analyzed, where this association of glycation and palmitic acid has elevated SRBP pathway, as also seen in the downstream effector molecules, which are HMG-CoR and LDLR required for lipid synthesis molecules. And moreover, we have also observed that there was reduction in the ATP levels due to this association of glycation and palmitic acid, indicating the mitochondrial dysfunction has taken place. So, cumulatively, we can say that this GHSA and palmitic acid are upregulating RAGE and SRBP pathway, and there must be a crosstalk between this RAGE and SRBP, which was indicated by inflammation, increased in the expression of NF-kappa B, and reduction in the ATP levels, indicating the mitochondrial dysfunction. And hence, this leads to the inflammation and lipid accumulation, we can say that, and responsible for diabetic tubulopathy. And this overall scenario can also, that is the association of glycation and lipotoxicity, can be used for the early detection of the DKD. So to conclude, that glycation and the lipotoxicity association upregulates RAGE SRBP axis, and it also induces inflammation and influences mitochondrial dysfunction. Earlier, we have studied the role of unsaturated fatty acid through a therapeutic perspective. However, in this study, we are actually confirming that this association of glycation and lipotoxicity can be used as an early detection marker for diabetic kidney disease. And hence, targeting this association can in future would be clinically relevant for early detection of tubulopathy as well as alleviating the progression of DKD. These are my references, and I would like to thank Symbiosis International Deemed University and the Symbiosis School of Biological Sciences for providing the infrastructure and fellowship. I would like to thank Glycation Biology Laboratory members for the support, and Diabetes India for providing me this support. Thank you.